Okay, we are back with mathematics grade 10 and algebraic expressions, where we establish between which two integers a given simple set lies. First, we need to define what is a surd. A surd is a root of a number that cannot be simplified any further. Okay, cannot be simplified any further. Let's give an example of a surd. A surd would be your square root of 3. Why? Square root of 3 equals something like 1 point what? Let me just check with my calculator. Square root of 3 equals something like 1.7320508008. And from our previous video, we would have seen that numbers like this that do not have a pattern, we call them irrational numbers. So sets are irrational. Irrational numbers. All right, knowing that we have square root of 3 equals 1.7320, we want to establish between which two integers. Now an integer is a whole number, right? So 1.73 can be found either between a whole number 1 and a whole number 2, and we definitely know that the value of square root of 3 is greater than 1, but is also less than 2. Where do we get that? Already 1.73 is greater than 1. So if this was a number line, you would have 1 here, 1.5 here, and then 2 here. Then somewhere in here you'd find your 1.7320 ... So we want to find between which two integers. The integer here in this number line would be 2 here and the 1 here. So we want to find a way in which we can find between which two integers a simple set lies. So here's how I worked it up. So we need to count the number of perfect squares that we can find, and I call this a reverse method. It's not an official method, but it's an easier way that I found in order to work this out for grade 10 learners. For example, 1 squared, we know that it's equals to 1. 2 squared is equals to 4. 3 squared is equals to 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100, etc. So already, as we can see, the reverse of a square would be applying a square root, right? So basically, if we were to line up 1 squared, line it up with 3 and 2 squared, and then afterwards say, hey, let's now then apply the square root of 1 squared and the square root of 3, the square root of 2 squared. What do you get for a square root of 1 squared? That's just the 1. Square root of 3 is square root of 3, and the square root of 2 squared is a what? it's a 2, whole number 2. So the method to do this would be to say, let's start with the perfect square, rewrite it as a square, and then apply the square root. Then we check, okay, which one is less than which one, in that order. In that order. So let's get it. You're given root of 3. They're asking you, establish between which two integers does root of 3 lie. What are you going to do? Alright, square root of 3, check your calculator, is equals to 1.73. And you know that 1.73 comes between 1 as a whole number and 2. But what is the square of 1? Square of 1 is 1 squared, which is equals to 1. And the square of 2, the square of 2 is a 4. So you're going to say 1 is the one that comes on the left. And the whole number 3, as the question is asking you about the square root of 3. And 4 line up like that. But you know that 1 can also be rewritten as 1 squared. 3 is the 3 from our square root, so we write it as just the 3. 4 can be written as a perfect square as what? As 2 squared. Then we are going to apply the square root in each one of them. And we know that the square root of 1 is less than the square root of 3. And it is less than the square root of 2 squared. But what is the square root of 1 squared? Square root of 1 squared is just 1, which is less than square root of 3, which is less than a 2. And then you can then say, therefore, root of 3 lies between 1 and 2. That's a shortcut method.